All right, guys, this is 9.2 notes, page 7. A school administrator is concerned about the amount of credit card debt that college students have. She conducts a survey of 600 students and determines 195 of them have credit card debt of $2,000 or more. Determine the point estimate for the population proportion. That's that formula right there. Again, guys, you can't do any of these problems without the formula. So we can find that formula on the first page of 9.2 notes. The number that have credit card debt, 195. The total number in this survey, 600. And the point estimate for this problem. Is it reasonable to assume that this distribution is normal? If it's not, then we're done with this problem. So cross your fingers and hopefully it's not. We put in all these values and 600 p hat, that's what we just calculated. 1 minus p hat, so whatever 1 minus that is, 1 minus. Hope you guys can see these things. If you ever get stuck, just email me and I'll either post a different video or maybe just post a formulas page or something like that. When you multiply those things together, you get 131.625. Is that bigger than 10? Certainly. The next part's kind of tough because now we have to say, of the 600 college students, that's our little n. Is that 5% of all the college students across the entire world? I don't know how many there are, but I'll bet that 600 is more than 5% of those. That's that big capital N. So we're going to say that this one passes as well. They both passed, so this is considered to be normal. Here we go. Construct and interpret a 90% confidence interval for these proportion of students that have credit card debt more than $2,000. To construct this confidence interval, we need the formula. So the formula for confidence interval is the p hat plus or minus the margin of error. The formula for the margin of error is this, just like we did on page 5 of our notes, and the standard deviation of that. The standard deviation of that, we got to plug in some numbers again. Our p hat, 1 minus p hat, or the complement of p hat, all divided by n, and n in our case is 600. So clear that stuff out. Here we go. 0.325 times equals, that's the numerator, divided by the denominator. I don't try to do this all in one step and then take the square root of that. The square root of that answer is, that's what we're going to use for our standard deviation. So that value erases and replaces with 0.0191. So far, so good. Now we have to find the z-score that makes it true. So I've drawn a little picture over here. 90% is in the middle. That means 5% straddle it. And our z-table only looks up, area to the left. So we want 95% of the area to be to the left. We could look up 0.95 right here, or just flip back to page 5. 90% confidence interval is one of these popular ones, and since it's so popular, instead of reinventing the wheel every time, we just flip back to this page with our critical value numbers. 1.645. That's this, 1.645. So we take those two numbers, I've got this one stored in my calculator already, times 1.645. Hope that makes sense for everybody. So we get the margin of error equal to 3%, 3.15%. So we start with our p hat, that's what this is, plus or minus The margin of error for my calculator is this. To get our confidence interval, and our confidence interval written in interval notation is 3.565. That means we are 90% sure that between 29.35% and 35.65% of the students will have credit card debt more than $2,000. All right, last one of this set. We're supposed to interpret a 94% confidence interval for this. And unfortunately for us, 94% is not one of the big go-to numbers. We can't look back on page 5 for that. But all these other values are going to remain the same, okay? So the standard deviation, all those numbers, exactly the same. Boop. So that is still 0.0191. Now we have to find this confidence interval. To find the confidence interval, it's p hat plus the margin of error. We need to find the z-score for it. Drawing a quick picture of what the I can't do these without drawing the picture, okay? We want 94% of the value to be within that number of standard deviations from the mean. So we need to find the number of standard deviations that represents. So if 94% is in the middle, that means 6% is divided equally on the extremes. Dividing those evenly, we've got 3 and 3. So we always want to have 100% of our area underneath this normally distributed curve. That means if I want to use my table or my calculator, I have to look up 97% to the left. So when we look up 97% to the left, we're looking up that 97% in the body of our problem. I had to grab my magnifying glass to find it, but this one's the closest one. It is 0.9699, a little bit closer than that one. So we reverse look up 1.88. So that z value is 1.88. If you don't want to use that table, they call it table number 2, it contains all the positive z values, then you can get out your calculator and clear things out. Let's try to find z value using our calculator. So we want to go into the distributions. When you're looking for z values, you want to use the inverse normal button on your calculator. And what area to the left do we want? 97% has to be written as a decimal. The average, we're going to assume that this is a standard normal distribution. And then the sigma is going to be the number of standard deviations away from the mean or the standard deviations. Drum roll. Let's see how close to 1.88 this is. 1.8807936186753009. So we can use 1.88. When we use 1.88, let's calculate this margin of error. 1.88 times 0.675. My bad. 1.88 times 0.0191, that's better, is 0.0359. We'll just round it to the nearest 10,000th. That's what our margin of error is. Now I got to add that to my p hat. P hat was 32.5% plus or minus this margin of error. 0.325 plus 0.0359. The upper bound, that's slightly different than what the notes say online. And the slight difference is where I rounded this number to, okay? So the online notes say 0.3616, and so I'm slightly off because I kept this out to a couple more decimal places. I will take that in consideration when you guys are doing your homework assignments. So 0.325, the lower bound is minus that value, minus 0.0359. Hit it. Again, the notes online say 28.84%, and we got 28.91% because I kept the significant digits out, one extra than what the notes did. Writing this confidence interval in interval notation, the lower bound always comes first, small to big. And what does this mean? Well, it means that we are 94% confident that the kids that go to college have they're between 28% and 36% will have credit card debt of more than $2,000. Again, I hope these videos are helpful. Stay healthy, guys, and we'll talk to you later. Shoot me an email if you have any questions.